So I'm going to be talking about significant digits, also known as significant figures. These are in reference to any number that we'll be seeing in chemistry in this course. What you know from grade 9 and grade 10 is if you have a calculation question, your answer, what to round to, will always be provided in the question. For example, it'll say round to 2 decimal places, round to 3 decimal places, and so on and so forth. However, starting in this course, what we're going to expect you to do is look at the question and specifically look at the numbers given in the question and know what number your answer has to be rounded to, right? So that's why these numbers, these significant digits, are important. So every number that you've ever interacted with has a certain number of significant digits. How can we identify them? There's a few rules that we always have to remember. Now, at first, they might be a little bit challenging, but the more you apply these rules, the easier it will get. So the first rule is that non-zero numbers are always significant. So any number that's not a zero, you can count to be a significant digit. So, for example, how many significant digits do each of these numbers have? Now, because in the first one, it's 3.1428, all of these are non-zero numbers, there are 5 significant figures. In this next example, there are 3 non-zero numbers, so there are 3 significant digits. Here, there are, again, 3 non-zero numbers, 3 significant digits. That's the easiest of our rules. Things get a little bit complicated when you have zeros. Now, our second rule is that sandwiched zeros, so zeros that are found between 2 non-zero numbers, are always significant. So let's look at these examples. So 7.053 times 10 to the power of 3. Okay, this is supposed to be an exponent. Now, to start off here, whenever you're looking at a number expressed in scientific notation, you never look at the 10 to the exponent part. Okay, so this never counts towards your significant digits. However, that first bit always does. So 7.053. So however many significant digits there are in this part, that's how many significant digits this number is going to have. So 7.053. All of the non-zero numbers count, but so does this 0 because it's sandwiched between 2 non-zero numbers. So there are 4 significant digits here. In this case, both of these zeros count. Again, they're both sandwiched between non-zero numbers. So there are 5 significant digits. And in this last one, there are 3. Now, the third rule is about zeros that are on the left side of the first non-zero number. So any zeros that are starting off in the number are never significant. So we never count those when we're counting our significant digits. So let's look at these examples. So 0, 0, 0, so 0.0056. So all of these zeros do not count. So there are only 2 significant digits in this question. So these 2 zeros that are starting off this number, so anything to the left of the first non-zero number, do not count. And then because this 0 is sandwiched between 2 non-zero numbers, it definitely counts. So 1, 2, 3, 4 significant digits here. And just the 1, because all of these are zeros on the left side. So this is 1 significant digit. Now here's where things get a little bit more complicated. So we're still talking about zeros, but this time we're talking about zeros on the right side. And these zeros sometimes count. Now, how do we know if they count or not? We have to see if there is a decimal point stated somewhere in the question. So if you see a decimal point anywhere in that number, then you know that the zeros on the right side do count. If you don't see a decimal place, the zeros on the right side do not count towards significant digits. So here, 4.300 times 10 to the negative 4. Remember, this is scientific notation. We never count the 10 to the negative 4. If you take a look here, 4 and 3, for sure they count. These zeros that are on the right side, now they depend. Is there a decimal in this question? For sure, there's a decimal right here, which means that these 2 count. So there's 4 significant digits. 200. Now there are zeros on the right side. However, there's no decimal place. So there's only one significant digit in this question, which is the 2. If I take a look here, 0.010050. These zeros do not count. 1, 2, 3, 4. All 4 of these count as per our previous rules. Now this one, does it count or not? It depends on if there's a decimal in the question, and there for sure is one right here, which means that there are 5 significant digits. In this case, 1, 2, 3 counts. This is a 0 sandwiched between 2 non-zero numbers. All 4 of those numbers count. There is no decimal, which means this last one does not count. So there are 4 significant digits there. Now the last one has to do with exact numbers. Now this depends on the context, and I'll give you a few examples. So exact numbers have an infinite number of significant digits. And these, especially in chemistry, are shown in terms of conversion factors. And what I mean by that, so for example, 1 dozen is equal to 12 eggs, right? And 12 eggs is an exact number, right? So there are 12 eggs in 1 dozen. So this particular number, if I'm given this in a question, this is going to have an infinite number of significant digits. Another example, 1 foot is going to have 12 inches. Now, it just so happens to be 12. There can be other numbers with infinite significant digits as well, but another example, right? There's only 12 inches in 1 foot. That is going to mean that this number has an infinite number of significant digits. So with these 5 rules, if you're looking at any given number, you should be able to identify if they have or how many significant figures they have in that particular number. Now, why is this important, right? So it's important when we do our calculations. And there's 2 main categories of calculations that we would do in chemistry. The first of which is addition or subtraction. And when you're adding or subtracting, what you have to look at is the decimal places that are there in the question given. So here's an example. I'm adding 150.0 with 0.507. Now, if I were to do this, I'm going to add all of these numbers up, put it into my calculator. This is the answer that I'm going to get. But as a rule, I'm going to round, or I'm going to take a look at how many decimal places there are in each number that I'm given. So in the first one, I've got 1 decimal place. And in the second one, I've got 3 decimal places. What I would have to do is go by whichever one is less. And because one of my numbers only has 1 decimal place, I'm going to round to 1 decimal place. Again, this is only when you are adding or subtracting. Here's another example. So the total mass of 33 grams of KCl and 56.50 grams of H2O2. So I would just add those numbers up, and I get this number when I plug this into a calculator, so I get 89.53. But because I know that one of the numbers I have has 1 decimal place and the other has 2 decimal places, I'm going to round to whichever one is lower. So this is only 1 decimal place. So I'm going to round to this spot. So I'm looking at this number, and I'm sure that you are familiar with how to round, but you always have to look at the number right beside it. So if it's 89.53, if I'm rounding off at the spot, I'm going to get 89.5. Now imagine for a second that this was 89.57, right? So any number that's greater than 5 in the spot right beside it, then I would have to round this up. So that's elementary school math. I'm sure that you're familiar with those rounding rules, but they apply. The only thing that we are deciding is how many decimal places we're rounding to. Again, for addition and subtraction only. Now, if we're looking at multiplication or division, which is the second type of calculation that we'll be doing in chemistry, we have another set of rules. So here's an example of a problem solving for density, which is something that you might have seen in grade 9. it gives you the mass and it gives you the volume. So you have to divide these two values to get your density, right? So I'm going to get this. So I have these values. I divide it. When I plug it into my calculator, I get 43.725. This is the answer that I get. Now, in terms of deciding how many or what place to round to, I have to take a look at the significant digits of the numbers in my question. So in this case, all of these are non-zero numbers, so I have 4 significant digits here. Now in this case, I've got one non-zero number, and I've got a 0 to the right. And remember, the rule about the 0 to the right is that it counts if there's a decimal place. And there is a decimal place, which means that there are 2 significant digits. So I have to count the number of significant digits in each of the numbers in my question, and I have to take note of whichever one has the least significant digits. So in this case, 2.0 has 2 significant digits. That means my final answer has to have 2 significant digits as well. And this definitely does. Notice that it has nothing to do with the decimal places like it is for addition and subtraction, but rather you just have to ensure that it has the same number of significant digits. So because 2.0 has 2 significant digits, my final answer is also going to have 2 significant digits. Now here's another example, again solving for density. So I'm solving for density by having 53.335 grams divided by 3.75 centimeter cubed. When I put this into my calculator, I get this number right here. Now take a look at how many significant digits there are in each of the numbers in my question. 1, 2, 3, 4, 5. All of these are non-zero numbers, which means that they all count. In this case, these are also all non-zero numbers, but I've got only 3 of them. So my lowest number of significant digits in my question is 3. Therefore, when I round my final answer, I have to round such that this number also has 3 significant digits. So the lowest number that I have in my question.